So let's get started with building Go CLI application. I'm Abhisek Pattnaik, full stack software engineer, currently working as senior software engineer at Impulses. To know more about me, please go to the link below. Before we start with building CLI apps, let's get some prerequisites. You should have some knowledge about basic syntax of Go. You may use VS Code or IntelliJ Golang IDE for writing the code. You should also have some basics of understanding about JSON and XML. And to give you some general information about the talk, all the relevant links in the slides are clickable, all the code images are clickable and point to the repository with the appropriate commit. Slide and app project are published in SpeakerDig and GitHub respectively. Relevant code commits are tagged as per the slide number. So this is the flow in which we will walk through this talk. I will provide the introduction to CLI app development, and we will get started with flag module in Go. We will learn how to parse various types of data from the CLI arguments, and then finally use all the knowledge we gained to build a CLI application to generate random data. Introduction to CLI app. Why do we choose Go for building CLI apps? Go provides a reliable, efficient, and scalable CLI application development. It makes it easy to build and it is fast. Go has a rich set of libraries for various tasks, such as manipulating text, files, and data. It also has built-in and third-party module support for parsing command line arguments and build CLI applications. CLI stands for Command Line Interface, where you write commands and its related information in textual form. You can launch programs and automate various tasks. That means you have native integration, or you can run the program using any other programming languages. It is easy to write and understand, unlike complex graphical applications. Now, let's see what Go's built-in flag module offers. We can implement parsing the command line flags with various data types, specify defaults, and also provide the usage description about each flag. It also allows to parse the data into custom data structures. Getting started with the flag module. Let's look at the syntax for passing the flags and data to our CLI app. We can use single or double dashes before the name of the flag, and optionally a value either with a space or equal symbol between the flag and value. Here is an example how we can pass the command line flags. Let us look at the code. So we check out the slide number 11 and to Go mode vendor, and as you can see here, there is a name variable that is declared, and we are passing the address of the name variable to the string var method with a name as the name of the flag itself and the default value as world, and the usage is as the name to say hello to. Then we parse the values, the arguments, command line arguments, and then we print the hello and the name that is provided. If no name is provided, then it will take the world as the value. So let's build it and test it out. So as you can see, we can provide double dash name and provide the actual name, and it will print the greeting. And if we do not provide any value or any name, then it provides the default value. Parsing data with flag module. The flag module supports various ways to parse the command line argument into such as to string, integer, boolean, float, duration of time, which is a non-primitive data structure. You can parse to any other custom data structures using flag.var and flag.func methods. We saw how we parse flags, where we need to provide the name of the flag. And often it happens that the name is too long to type. For this, we can use flag aliases, which are shorter way to pass data to the flag variables. Let's see the code. We will switch to the slide 14. Here you can see we have declared a variable name, and we're using the same variable name for having a longer version of the flag and a shorter version of the flag. And we parse the data, and as before, we are printing the data. So let us build that, and let's use with full version and with a shorter version. As you can see, we were able to provide the name to the longer and the shorter version alias. If we check the help, and we can see that we have two different flags defined with a shorter and the longer version in the usage. So conventionally, we write a shorter version as the first character of the longer version. It is often required that we have multiple flags, and there are longer flag names that we need to type. To handle it gracefully, with better maintainability and with ease, we can make use of GetOpt third-party library. It provides a clean way to define the aliases and also show the usage in a better way. Let's look at the code. We'll switch to slide 15 and make a go mod vendor. So here we use the GetOpt third-party library to declare the longer version of the flag using the flag model, and using GetOpt we define the alias with the formal name same as the flag that is defined and a shorter name, and then we parse using GetOpt, and we give the defaults, print the defaults. So let's build and look at how it appears. As we can see, the shorter and the longer version of the flag appear in a much better way than the previous way of showing the usage. A user of the CLI app might not know what flags are available for CLI app and how to use them. To find out, we conventionally use -h or --help to show the usage of the CLI application. Let's see how to implement that. Let's see the code. We check out to slide 16. In this, we have a name and repeat two different flags. We get the total arguments that are provided in the command line using the os.args. We discard the first argument, which usually is the name of the command line program that is used to run. Then we define a help flag and defaulting to false or true based on the total number of arguments. So if the total number of arguments is 0, the help will run, and we will get the defaults, the usage of the flags. So let's try that. Let's build it, and without giving any arguments, as we can see, we got the help. Even if we provide -h or ~help, we get the usage of the command line. You built a nice CLI application, but a creation without a name is like a ship without a sail. Let's give a name to our application. For example, greeter CLI. We use the new flag set constructor function to create a new flag set with a name. Let's look at the code. We switch to the slide number 17. Here we create a new flag set with new flag set. Here we are using the get_opt library, and we can provide the new name that we have, greeter CLI, as the first parameter to the new flag set constructor function, and we use the new flag set to define the flags and also provide aliases. So this can be used with the flag module as well. And then we parse the arguments. If help is true, we provide the usage. So let's see. Let's compile this and provide the help. And as you can see, when we see the help, the usage of greeter CLI is as follows. So you can see the name of the CLI application that we have given. As noted before, we can parse a CLI flag value to a custom data type. For that, you need to implement the flag.value interface for the given custom data type. Let's see how to implement. We go to the slide number 19. Here we have a address structure, which is a custom data type. Then we use the address structure as a pointer in the address value, and we implement the get and the value interface. In the value interface, you implement the string method and the set method. In the string method, we simply return the string value of the address, and in the set method, we split the address that is provided in the given format and then assign it to the address structure. So let's build this and see how we can use it. As you can see here, it is expected in the format street, city, state, pin code, and country. Let's provide the address in the same format. And then, as you can see here, we have given the address in a string, and using the set, it has assigned the address to the corresponding fields in the address structure. We can also use flag.func method to parse and extract the required data from the CLI flag value. This might come in handy if a custom parsing function is required. Let's see the code. Let's go to the slide number 20. Here we have defined the flag num, which will take a string and extract the number value from that and then assign it to the num, which is this is a custom parser function that we have written. So let's compile it and run it with num, and we can write any characters, and in between the characters we provide the number. Now that number is parsed and it is extracted, assigned to the num integer, and then we print the number. As promised, let's see how we can provide a JSON file as input and parse it. The JSON file can have mixed data type for a given field. So let's look at the JSON file. So we go to slide number 21, and this is the input JSON. As you can see here, we have an alias property which is a string with a comma separated aliases, and the same aliases property is a array of strings. So we will see how we can process this. To parse the input JSON, we implement the flag.value interface and unmarshal the input to JSON struct using the flag.var method. So let's try that. Okay, let's walk through the code. We go to slide number 23. So here we have a JSON CLI. And in this JSON CLI, this is the input. This is the input which will store the JSON values, and this is the item. So this corresponds to these values, and it is expected the aliases will be a slice of strings. Now, using the var method, we define the JSON input flag. JSON input flag is defined as such. We provide the input file as a pointer, and then define the set method. Here we extract the JSON, read the JSON file, and then parse the JSON, unmarshal the JSON to the structure, the input file struct. So while unmarshaling, here we can see that we create a alias and unmarshal the file, the JSON data. We have used the aliases as any in this case, so that the aliases with mixed data type is assigned to this aliases field, and from here we check if the aliases is a string, then we split the string using comma separated values. Otherwise, if it is a list of strings, then we run through the list and convert it to a string and assign it to the aliases array. So we can also use alias.string likewise, and let's build it and check JSON CLI. Let's see the input file. We pass the input file using -i. Let's see the flags which we can use. As you can see, -i is for providing the input file. We provide the input file and it processes the file appropriately without any errors. As per the print Now, since you have gone through many parts of the flag module, let's see how things are implemented into. You can find the implementation source code from the given link. So let's see the browser. Uh, the parse one is the function which parses the CLI flags, and that is implemented likewise. And you can see here the formal name if it is not there, and if we have given the help or h as a flag name, then we will get the usage of the CLI application. So this is how the flag model is implemented. You can go through this, how the parse function works, and how the parse function for each argument it parses. Okay. Now we go through the final part of the session, generating multiple random data. Let us start with generating a random number between a range given a mean and max values from the CLI argument. So let's switch to the slide 26. Here we see we have a min and max variables, and those are bound to the min and max flags, and we have alias for min as a small m and capital M for max. And then we have a check where the max should be greater than min. We create a random generator and then create a random value from that and print the value. Let us build and check random CLI. Okay, we need to go mod vendor, and then we build it. Then random CLI, small m and capital M. We provide the min as 1 and max as 10, so we get a number between 1 and 10. If we provide max as 100 and min as 10, we get a number between 10 and 100. Now let us try generating random values using a third-party library. We will use Faker library, which generates various types of valid random data such as address, name, text, etc. So let's go to the slide 27. And make a go mod. So here we have a student structure with a name, age, percentage, height, active with the given data types, string, int, float 32, int, boolean. And in the meta, we have a description with a string data type. Now we will be using GoFakeIt library, and we seed the library, and then we create a we create random values for the fields of the struct using faker.struct method. So then we dump the data in the structure. So let's compile that and see. So as you can see here, we have the name, random values assigned to the name, and other fields of the structure. We saw how we used the Faker library to generate random data, but the data itself was not meaningful. We can provide some hints to get some meaningful data. Let us see how. So let's go to the slide 28. And here we have a address field. And in the address field, we have given some hints like street, city, zip, state, and country. This will generate meaningful data for the given fields considering these hints. So we do the same. We again run the faker.struct with the address and we execute that for mod vendor and build the code and again run it. So as you can see here, we get meaningful street values, city values, pin code, state, and country. We can also generate data using custom functions using the Faker API. Let's see how. So we go to slide number 29, and here we have the address structure. From the Faker, we generate the address values using faker.address, and we assign the corresponding address values to the fields in our address struct, and then dump the address value. So let's build it and run it. So as you can see, again, we got appropriate random values using the Faker functions. Let's see how the GoFakeIt library is, what the API of GoFakeIt library provides. So we have various functions and the struct method that we used. So there are multiple different functions available for generating person, addresses, and other miscellaneous things. So you can go through the API for learning more about how the GoFakeIt works. Now, let's see. Here we are having some of the libraries that we used for debugging the structure so that we can pretty print the struct and find what is the data in that. So you can refer this. Out of that, we are using spew.dump and val.ast. So this can help you make a log-based debugging. Let's see how we can embed data in the CLI app so that we can generate this embedded data later after the build based on command line flags. So let's check out slide 31, and we go mod. So here we have a person schema, and we are embedding that person schema in our Go application as defined here with the person schema variable. and then we generate a person. If the generate flag is present, then we generate a person schema. We generate the person schema. So let's see the person schema generation. Here we create a file and then write the person schema to that file. So let's see, let's build it. So here we will be, we can run the random and generate. So here we generated the person schema file in the root directory by providing the command line argument as --generate. And one thing you can note here that the directory structure that we have is we have a command cmd directory and we have an internal directory. In the internal directory, whatever we have, it is internal for this application, and no other application outside of this can import this directory exported values, and cmd is for having a command line for that. And you may also take a look at the make file, which builds the command line application. So we have go build, output directory is specified as bin, provide the LDB flags if applicable, and then provide the structure directory structure that will be built. So go generates the directory, the command line applications with the same name as the directory where the main file is located, and hence we got the random CLI binary file in the bin directory. As we saw, we were able to generate the embedded file using CLI flag. Previously, we have been generating only a single set of data. Now we will look at how to generate multiple random sets of data. We will generate a few person details using the number of persons count from the CLI num flag. Let's look at the code. So we will switch to slide number 33. So here we have the command line application. We have a package directory where we have defined the details of the person that we need. So, and this will also have a new person factory function, which will construct a person using the faker struct, and we also have provided hints for the person, that is the address for the first name, last name, and then we create a new person. So this is the internal CMD, which will generate the persons based on some number of persons that we want to generate. And here the command line application will simply call that method, call that function, and generate function persons, and number of persons will be provided from the CLI. By default, number of persons was 1. And then we are printing the persons which we are generating. So when we print this, then person.stringer, this stringer interface has been implemented, and this is executed, and the value return value is printed in the command line. So let's build it and provide the number of person. We can provide a alias using -n. So let's generate 10 persons. So as you can see here, we have generated 10 persons with address values. We generated the data one after the other. We can also generate concurrently using Go routines. We make use of wait groups and Go routines. Let's see the code and see how we can generate the data concurrently. Let's switch to slide number 34. And here, if we go to the internal CMD person, we are using a wait group and we are generating the data concurrently here. We have a Go routine and we have a wait group to wait for all the Go routines to complete. So in this case, all the Go routines are run simultaneously. So let's build it and run it. So it gives us a same 10 number of persons, but all these persons are generated simultaneously, and the faker library all supports the simultaneous generation of person using it supports constructor concurrency. Sorry. So previously the concurrent threads ran all at a time, but we can also restrict the number of concurrent threads that run at a time, which generates the data. We can make use of buffered channel to achieve this. Let's see how. We go to slide number 35 and go to the persons. Here we go to main and let's see the number of persons we accept using the num flag and the concurrency using the concurrency, and we are printing based on this. If we go to and we pass the concurrency that we get from the generate person options through the generate person options to the gen persons function, and here we create a buffer for the buffer for the channel, and then we fill in the buffer, adding things in queue till the buffer is filled, and then we run the Go routine. As and when the Go routine succeeds, the buffer will be cleared, and from here we wait for the Go routines, all the Go routines to be finished, and once that is less than the maximum buffer amount of data, then this is returned, and we get all the persons from here. So let's build it. And so print the data. So this will use the concurrency of 8 as the default, or we can also specify the concurrency. As you can see here, we specify the concurrency as 3, and we generated 10 persons data. Now that we have learned how to generate random data, we will use that to generate XML file output with random data. We will have the CLI flags for specifying the output directory and the name of the XML file. Here we also output the embedded schema file along with the XML. We pass the number of records to be created using -n, the output directory using -o, and the name of the XML file using -N, and optionally pass the concurrency as well using -c like before. This will create a XML and a XSD schema file for the XML. Now let's dive into the code. So we switch to slide number 37. So if we go to the command cmd directory and check the available flags which are bound, we have a num flag, we have a concurrency, print, name of the XML file, output directory of the XML file, and force if we want to overwrite the files in the directory. So we will be outputting it to temporary directory. So let's delete that, and we have some aliases. So let's first build it and see how we can generate XML file and the associated XSD file, and then we will look at the code. So XML CLI, and we use the number as 10 and the name of the XML as first gen, and the output directory to be temporary directory. So here you can see we generated a XML file, and we have the XSD file associated with that. This XSD file we have embedded from here using go embed, and then we generate the XML file using the XML struct that is found here, and the persons are the items of the XML, and that can be added from here. So persons data is the same person struct, and the associated person data. So here again we are using the buffered concurrent way of generating the data and creating the XML. So in this internal CMD file, we create the XML using generate XML, and this will write the data to the XML. We create an encoder for the XML, and then we encode the XML. After that, we create the XML file. So this will check if the file is existing, and if it exists and the force is not true, then it will give this error as file already exists. Otherwise, it will create the file and generate the person, generate the XML, create the schema file, and then return. So schema file is also specified here, how it is being written to the disk. And then the schema file is after returning, it will print the concurrency likewise. Till now, we created randomized data, but we can also pass some predefined data for a few fields, and the rest will be random data. We can do that using a JSON file as input with the given data. We will generate the placeholder JSON file and the JSON schema for the file using the -g flag. This will create the files under the directory passed using the -o flag, and we will input the pre-filled JSON file using the -i flag. Now running our CLI app using the same parameters for generating the XML as before, we get the XML and XSD files created in the output directory. Now let's look at the code. We'll switch to slide number 39. So here we have a few more flags like the input flag and the generate flag. The generate flag will generate the input JSON and schema, and input flag will input the pre-filled JSON data. So this is the schema, input schema, and this is the placeholder input schema, input JSON. So these two files are embedded. This is JSON schema that is embedded, and then this is the input JSON file that is embedded. And those files are generated when we run -G when we generate using this, and we have a few aliases as we usually do. So let's first remove the temporary directory, and we can output generate. We'll go mod vendor. We'll build the CLI application, then see how we can generate a input JSON. So here we created an input.json placeholder file. So here we can provide the first name, and the rest of the fields will be randomized data. So let's see if it is generate input JSON, if -g command line argument is provided, then it will create a input JSON file, and if we go into that, we will generate an input JSON file in the given directory, and also we will create a schema file along with that. So this is the input schema file, and this is the input JSON file. Now, if -g is not there, and we want to generate the XML file like before, so here we provide the predefined person. So the person is taken from the input file. If we have a input file path provided, then it will generate a pre-filled person. It will read the input JSON file and unmarshal it to the person info and return that. So that is added in the person info, and it will pass to the XML generation. So here in the XML generation, everything is as before, but while generating the person, we also pass the predefined person data. And if we check the generate person, here we are copying the predefined data with the randomized data. This is the new code change that we have, and for copying we have this code. Now let us see, since we have already added a first name to the pre-filled JSON, so we can input that input JSON, and we can name the XML file as Abhisek and create 10 records, and the output specified will be temporary. So this will create a XML file with the first name pre-filled as Abhishek, and other fields are randomized. Now if we provide the last name as well, and we generate the same thing with -f so that we can force the overwriting of the XML file. Then if we go to the XML file, as you can see here, we generated the randomized data with some pre-filled data for the first name and last name for all the records. So we discussed how we build a CLI application with randomly generated data, input JSON with mixed data type fields, embed and generate XML and JSON files with pre-filled data. So here are the key takeaways. CLI apps are important tool for developers, and Go is a great language for building them due to its strong support for command line interfaces. The flag module in Go is a powerful tool for parsing command line arguments and building CLI apps. To generate data concurrently, you can use Go's powerful concurrency features such as channels and Go routines. You can override randomized data with predefined data. When building CLI apps in Go, it's important to keep the user experience in mind and provide clear and helpful error messages when command line arguments are incorrect. With the techniques covered in this talk, you'll be able to build powerful and flexible CLI applications in Go that can generate randomized data quickly and efficiently. Here are some of the resources that will be helpful for you in your journey to become the master of CLI. The first one is the repository for the workshop, and then there is the presentation for the workshop, which you can get from these links, and awesome list of CLI applications, a list of CLI applications which will be helpful to understand how the CLI applications work. Flag module is the flag module API provided in the Go documentation, and then there is a flag module source code that you can go through. The getopt library that we used for aliasing, the faker library that we use for generating fake data, and if you want to build a powerful and more complex CLIs, then Cobra framework will come in handy. If you have any questions, do reach out to me. Kindly forgive me for any mistakes that I might have made, either verbal or otherwise. Please scan the code and provide anonymous feedback. Thank you.